All right, hello everyone. Welcome to my channel. My name is Thomas, and I do videos on educational matters. Today we're doing, I believe, I don't know, I think it's our 29th video here on the reciprocal system of theory from Dewey B. Larson. Larson um, worked out this theory in the 20th century. He died back in 1990, and since then the theory has been updated um, by a number of different people, but especially Dr. Bruce Perret, and but he died back in 2020. And so I think the theory is really very important and very impressive. Um, but I also feel that it is in danger of being set aside and forgotten. So I'm trying to put it back out there so that some people can become aware of it. And it's a hard theory. Really, in order to kind of get to understand the theory, you really need to have read a few of Larson's books, because if you just read one of them or so, you end up kind of thinking, oh, he's just pulling this out of no place. Where is he getting this from? But once you see that you've read a few of his books, you see that he applies it the same way every time. It looks arbitrary a little bit at first, but you can see the consistency, and you begin to be able to see where he's getting stuff from, how he's getting it, and what his process is. So that's a little bit why we looked at his book called The Outline of the, or his speech called The Outline of the Deductive Development of the Reciprocal System. And now we're looking at his last book, Beyond Space and Time. Now, the basics of Larson's theory is that, just to recap briefly, the universe of the Greeks was a universe of matter. And then 2,500 years later, Einstein comes along and he says E equals mc squared. Therefore, energy equals matter times the speed of light squared. They can be converted one to another. And so the universe looks like it's made out of matter, but it's really ultimately made out of energy. Larson comes along later that century, 25, 30 years later, and he says, well, if E equals mc squared and energy can be converted to matter and vice versa, that means that neither one of those things can be the most fundamental thing in the universe, and there's something that underlies both of them. And he says that that thing that underlies both of them is really kind of like the c squared part. It is motion. The universe is made out of motion. And other people have come up with that in the past, but they have never been able to make it work because they didn't redefine motion or define motion precisely. For Larson, motion is the relationship between space and time. So basically, you end up having a fraction, X amount of space in Y amount of time, or vice versa, Y amount of time in X amount of space. And both of those relationships are motion, along with all the other relationships that we know from scientific theory: acceleration, magnetic charge, compressive pressure, density, mass, energy, force. Those are all relationships between space and time. Now, in Larson's postulates, he basically says that space and time are reciprocals of each other. That's where we get the name the reciprocal system. Space and time are the same, but they are reciprocals of each other. They don't exist separately. They only exist together in motion. And so he basically takes that kernel. He has two postulates. takes those two postulates and applies them step by step, if this, then that, if this, then that, to um, his theoretical universe. So he basically constructs a theoretical universe based on those principles, and then compares it with the actual universe that the scientists have discovered through measurement and observation. Unfortunately, some of those measurements and observations have been fudged, and they screwed up Larson's theory because Larson believed in them. But we'll get to that eventually later. Now, today we were looking at at Beyond Space and Time. So this is his final book that was published posthumously after he did all his books on physics and astrophysics and chemistry and astronomy and all of the hard sciences. His wife published this book after he died about metaphysics. And we're here in chapter 5, which is called Levels of Existence. And this is where we left off. He's basically attempting to explain life, where life is coming from. He's looking at chemicals, the chemical world, and he's saying that chemistry evolves, or it progresses based on aggregation. These particles are all putting themselves together, and then he's distinguishing that from the evolutionary process. So, he's saying that the process of aggregation proceeds slowly because of the very low probability of the right kind of contacts. In the biological realm, evolution, on the contrary, the increase in complexity is inherently cumulative. A protein molecule could form directly from its constituent atoms if the right atoms were available in the right positions at the point of formation. Just as an Anthropocene molecule is known to do, but it is not conceivable that the coalescence of any number of single-celled organisms could produce a polar bear. The evolutionary process as we find it in living organisms is not merely a matter of aggregation, like the formation of a molecule. It is a long process of gradual development by trial and error, in which the new is derived from the old by modification rather than mere addition. Another striking point of difference is that in biological evolution, the new replaces the old, either partially or completely, whereas in the inanimate process of aggregation, the new and more complex structures are always a tiny majority, the relative proportions of various structures being determined almost exclusively by the relative probability of their formation. The dinosaurs, which once reigned supreme in their environment, again, Larson is using these, facts that he gets from science that are mainly merely speculations, about the dinosaurs and so on. The dinosaurs, which once reigned supreme in their environment, are now extinct. But any chemical compound which ever predominated in a particular environment still predominates in that environment. The sands of the Mesozoic era, when the dinosaurs roamed the earth, were grains of quartz, just as the sands of today. Again, we find that living organisms are unique in their ability to utilize food. That is, they can extract from their environment substances that are composed wholly or in part of the materials needed for the growth of the organisms. They can break these substances down into simpler units and can reconstitute them into the specific forms that can be used by the living bodies. Inanimate structures, on the contrary, can only grow by obtaining from the environment some kind of matter that is capable of being added directly. The most that they can do in the way of adapting existing material to their use is to pull a loosely bound atom or atomic group away from some other structure. An even more significant difference is connected with the basic physical principle known as the second law of thermodynamics. Inanimate matter obeys the second law implicitly, whereas living matter behaves in a manner that seems to defy the law. By way of illustration, a wooden fence post will burn if any part of it is momentarily exposed to a high temperature. The second law says that any naturally occurring process, such as this combustion of the fence post, results in a decrease in the availability of energy, and accordingly, we find that the available energy in the carbon dioxide, water vapor, and ashes, the principal combustion products, is substantially less than that of the original fence post. A naturally occurring reversal of the process would violate the second law of thermodynamics, since recreation of the fence post from the products of combustion would increase the availability of energy. But this is just exactly what happens in the living world. A seedling tree takes the carbon dioxide from the air, extracts the water and the constituents of the ashes from the soil, and within a few years it has recreated the fence post as a tree. We cannot take the stand that the growth of a tree is not a natural process unless we give that term an altogether different meaning than it now possesses, the meaning that is utilized in the statement of the second law. It is therefore evident that the living world and the non-living world are not governed by the same set of rules. Okay, now in his long-winded manner, he goes over a little bit of the word I use is historiography, but what the literature along these lines, and some of the greats, Percival Bridgman, and other people who have philosophized about this. But I'm trying to get to the point where Larson really explains in his system what is life. And we started talking about that before, where it has to do with this interregional ratio, and that there's a huge amount that gets lost in the translation when you are working from one sector of the universe to another. And there are four different sectors of the universe, with the speed of light dividing 2 from 2, and then so this side is really this, what he calls the time-space universe, even though he probably should have called it the space-time universe. This is the part that we're familiar with, the material sector, that's moving slower than the speed of light. And then this half is the cosmic sector, moving half faster than the speed of light. But then within those two sectors, there's also a mini sector. Here he calls it the time region. Here he calls it the space region. And the boundaries there are the unit of space and the unit of time. So everything over here that's within a unit of space crosses this boundary and goes into this other world, which is all time. Everything is time, because it can't be space, because of the discrete unit postulate within his first postulate, that time and space are in discrete units. They are quantized, meaning that you can only have one unit of time or multiple units of time, but you cannot have half a unit of time or a third of a unit of time. Once you get less than 1 unit of time or space, either one, then you have to flip it over and go with the reciprocal aspect, meaning that you're in the realm of time over here, in the realm of space over here. So there's really 3 boundaries, and they create 4 different sectors. Now, but if you are trying to make measurements or glean information from a sector that you're not in, we're in the time-space region, meaning we're in this slower than the speed of light range of the material sector, but we are in the larger than 1 unit of space realm of the time-space region. We're not in the time region. So if we go to the time region, or if we go over to the space-time region, we are crossing a boundary. And then when you cross a boundary, you have to put a reduction on the information that you're getting from that other sector. So if you look across to that other sector and you see one, one unit, you actually have to multiply that by the interregional ratio to figure out how many units there actually are there. So when we see across the boundary, we only see a small fraction of what's going on there. And Larson calls that the interregional ratio. And he uses a formula to arrive at it. The interregional ratio, usually for atoms, is 156.44, which is really like 2 to the 7th power times 9/7. The result is or 11/9. I'm sorry. And so that, but it also could be 10/9, depending on certain circumstances. So he adjusts the interregional ratio. But then when you're dealing with, he says that the universe is made out of space and time. Space and time are in 3 dimensions, 3 scalar dimensions. And then when you cross into the atomic realm, it's really 4 dimensions. And so when he's translating over from the cosmic sector into the material sector, he has to use this interregional ratio, 128, to the 4th power, and then multiply again by 8. So the number that he ends up getting for the interregional ratio from across the boundary is actually 2 to the 31st power, which is approximately 2 billion. So when we are translating from that sector to our sector, we are only really able to see 1/2 billionth of what's going on there. And where he's saying that there needs to be, I'm trying to find it here in this chapter, and as Larson is wont to do, he goes on and on and on and on and on and on about certain things, and then he gets to the point. But when he gets to the point, it's, after 20 pages of having to labor through it, and so nobody ends up seeing his important points because they gave up sifting through all of his stuff. So that's really where he's getting where life comes from, is that it's a one-to-one. He says that life is a one-to-one communication or control of a material unit and a cosmic unit. So the cosmic unit, he calls it the control unit. And so this cosmic unit, and the cosmic, the moving faster than the speed of light, has to do with metaphysical matters that are beyond physical, in particular things like communication and thinking and memory and consciousness in general, and control. And he says that the cosmic unit takes control over the material unit, and that's really what constitutes life. But the only way that can happen is if you have a one-to-one reaction between the two. It takes one control unit to control one physical unit. But the problem is that you got this interregional ratio of basically 2 billion, a little over 2 billion to 1. So what that means is that in order to basically occupy one of these cosmic units, when we see one of these cosmic units, that means that there are actually 2 billion of them. So one material unit is not going to be able to accommodate one cosmic unit, because when you have one cosmic unit, when you see one cosmic unit, you really have 2 billion of them. And so over here at the material sector, you actually need to have 2 billion units in order to satisfy the need to just occupy one of the units that we see of the cosmic unit. So he says that, you have to have an aggregate of 2 billion atoms, in order to be complex enough to occupy one cosmic unit. And he says that, that is DNA. So DNA is the most complex molecule that we're aware of, or at least at the time he was writing this. And DNA is really the least complex unit that will do the job, that will occupy those life units or control units. So that is his explanation. I will try to find how he goes through the interregional ratio here, and we'll discuss that tomorrow. But that's just how he comes up with life, and we'll get into that further tomorrow.